So let's start from what is SOTI. SOTI stands for State of the Internet. What is that? We, as Akamai, have a huge platform deployed all over the Internet, and we see a lot of traffic. We started actually, hopefully it works. Okay. We started late in 1998, and what we did is we created this platform through the years. Initially was for CDN, so content delivery close to the user, and for acceleration of content provided by web servers. Through the years, we have also implemented security feature on that. Actually, we will see, to put in a context, we have a huge amount of data in terms of security that we put quarterly available to everybody. So we produce these SOTI report, the state of the internet. Is produced quarterly, is freely available, together also with graphicals. If you like then to go to, after the presentation, you come to our booth, we will show you how it really works and how to download it and to have it. What is the Akamai platform today? I hope it will work. This is our platform. It's made up of 200,000 servers spreading in 110 countries, and actually we have presence, networking presence, in more than 1,400 networks. So we deliver from 15 to 30%, depends on the kind of the day, of internet and web traffic. And those are the data that we serve, 30 terabits per second and 40 million hits per second. By the way, anybody of you has any idea of how many countries, nations are there in the world? There are 196 countries. If you consider 196 countries compared to that data, 110 countries presence and 14 networks, 14 ISP, 14 transit networks. We have a huge deployment. Plus we serve a lot of, let's say, good customers, which give us a full pictures of what is going on to the internet. That is why actually we do that. What if, in terms of protection, what do we do protect? We do protect exactly what the normal, let's say, end user, what do you do when you're at home? You will need to go to first the DNS, check the address of the web that you want to surf, go to the web, and then probably gather some data from the database, from the backend, from the Oracle, from whatever. So what we do is we protect, in the red area there is the client, and we protect the DNS. So the DNS request, we have a service to protect DNS environment, either as primary or secondary. It doesn't matter. After the URL has been retrieved, we have a platform for web application servers, web application firewall, sorry. The web application firewall is on the far right and also on the far west. It's not one-to-one. We will pop them up on all our servers at the same time to ensure that also our protection is closest as possible to the end user or to the attacker in some way. To protect the web content as a web application firewall, as well as we have a solution to protect all ports and LoRa protocols for the data center. This is both in terms of layer 3 attacks, so volumetric kind of attacks, as well as I said, web application firewall, so layer 7 attacks. Consider those are not three different platforms, it's just a logical view. It's actually the same platform with different services. So what we do with this data, when we gather some data, because everybody which is crossing our platform naturally leaves some information to us. What we do is we use actually that data. And those are the numbers, just to put in context why we produce the state of the internet. 2 petabytes of stored data gives us a great visibility on what is happening actually on the internet on a daily basis and on the quarterly and yearly one. Daily we see more or less 20 terabytes of data. So we produce also hourly queries. Consider This is not just data that we use to produce quarterly reports. Those are data that help us to enhance the security posture, to define more granular rules or less granular rules on the firewalls for the customers. And we retain them for 45 days. 45 days means that we can also gather some statistics. You see there, yes, accuracy. Our services are very accurate, but more interesting is client reputation. With this client reputation, saving the data for 14 days, we can see the behavior of the single clients connecting to the platform. And so understanding, is this a good guy? Is this a bad guy? Or is doing something normal, is just surfing a URL, but in the past, he was running a botnet. He was running some backdoor, something. We know that, so we can rank the client in terms of its reputation, and then understand we would block it, we would not block it. Again, all those data are also freely available if you check on the top left, state of the internet. Just URL, it's open. Naturally, it's on HTTPS. But you can have all this data. So in terms of Q4 2015, what happens over the internet for what we have seen? There are some interesting things. Each black bullet is a DDoS attack, volumetric DDoS attack we are talking now. What happens if you see on the far right, in fourth quarter of 2015, the attacks are concentrating in an area which is slightly below 100 gigs. They last for less time, and they're concentrating there. And that is because mainly of two factors. The first one is reflection is much better than infection. Infection needs a lot of effort. When you go for reflection, then you can run maybe smaller in terms of time, so more little attacks, lower than 100 gigs probably, but still very, very effective, and you can do it easily. Why? Because of the booter and the stressors that are there more or less for free. That's also affecting the time of the DDoS attacks itself, because booters and stressors normally allows you to run an attack for probably 1,200 to 3,600 seconds, so from 20 minutes to 1 hour. That is why we see a little decrease in the attacks, but they're becoming more and more effective. And on the other hand, they're also costly for who runs them many times. So, and in this space, what are the most effective, the most attacking countries? Well, you can imagine the usual ones, China, US, Korea. But the major fact in 2015, in the fourth quarter, is that Turkey pops up with 22% of attacks suddenly. It's never been in our radar. Immediately, in the last quarter, they pop up with these numbers. Why is that? Well, first of all, Turkey was not really running attacks. It was used as a reflection countries. So that's why we see this data. We naturally also the reflection attacks, if the IP address is spoofed and whatever, we see it as a real attack. And probably there's not that much coincidence, or is there, but they started being active slightly after this problem with the shutdown of the airplane, the Russian airplane, etc., etc. So there you see also what we normally see, the difference between enterprise protection and the information warfare, where you switch the context actually from what's happening inside an enterprise and what's happening in the internet level inside a country, or inside a country, the battle of the countries. I shouldn't say this, but anyhow. In terms of frequency divided by industry, those are the data. Gaming is the lion. Why is gaming the lion? Q4 15, well, it's Christmas. What if I buy a game online and I cannot use it because the platform that I want to use is hit by a DDoS attack? And that's why. Software and technology, obviously, everybody's gone on a cloud, everybody has servers on Amazon or whatever. They can be both hit by attacks, either they can be used as reflection or amplification kind of attacks. And another important things to consider is attacks are getting more complex, time by time. So what we see in the percentage of the multi-vector attacks is single vector attack is just 44%, less than a half. All the others use at least 2 to 3 technology, and we will see it probably slightly later. Yet in terms of attack vectors, see what is happening is also the most widely used are chargen, DNS, NTP, and as well UDP fragment. We will come to the UDP fragment because it has a pretty interesting meaning. But naturally, chargen, DNS, and NTP gets you a lot of power in terms of amplification of the attacks. So they're worth to be used. This is a comparison between the different quarters. So the below blue line for each kind of attack is the last quarter. And I put a plus where you have an increase. So as you see, except from ACK, you have an increase in charging, in DNS, and in NTP. Very often, when an DDoS attack is run using UDP technologies, there's also another technique used, which is normally the attackers tend to put the MTU, the total MTU, to 1500 or over 1500. 1500 is normally the maximum. MTU stands for maximum. So UDP fragment is probably not just the attack, it's just a reflection of the others. Because when you go for an MTU, which is bigger than 1500, what happens is you have to fragment packets. If you have to fragment packets, you will obviously see UDP fragmentation increase. But that's not probably attacks. That's a side effect of other kind of attacks that are run here. Is that difficult? Not that much. This is an example of how you can run an NTP amplification attack, naturally done on a single machine. But it's just enough if you put the mon list command. NTP, if it's vulnerable, as the monitoring open, which means I send out a single UDP packet just saying, can you tell me what time is it? And he replies to me not only when the mon list is on, it will reply not only with the timing, but also with the list of the server that have accessed the NTP server in a given time. So you can go up to 500, the list of 500 servers. Spoofing the address, it's easy to get a reflection attack, very, very amplified. Countermeasure, pretty easy, in fact. ntp.conf, disable monitoring on the NTP server. Does anybody remember this phrase? Comes from the very old time. I've used a couple of times. I'm not that young, unfortunately. This is a string that was used actually on the packet switching X25 network to understand if the mix that you were connected to with your modem was actually replying correctly, was working effectively, because this has all the characters of the alphabet in it. And that is why it was used. With the echo reply, you could understand if the mix was properly working. Is it used anymore? No, X25 luckily is not used anymore, but we still have the chargen. Port 19. What happens? You send just one packet, you ask for the UDP, you ask for the chargen, and he replies with all the character list. So again, very effective amplification. And what we have experienced in terms of capabilities, in terms of what we have seen till now, remember, differentiation of the vectors of the attack and using multiple kind of attacks all together. So what we have seen has been a campaign, actually this is not from 2015, but it's the biggest that we have seen on our platform, coming and running for 21 days together on a single customer and using different kind of technology. Oh, luckily this is good. Was hitting infrastructure as well as web, authoritative DNS, and DNS reflection as well. It lasted for 21 days. Those are the peaks that you see. And this is just a big picture to let you understand how the attack was carried on. What we saw effectively, this is the router view. If you check the red, under the red, total mitigated, you are on 31.7. So 317 gigs mitigated in 25 days. As well as there was DNS attacks with peaks of over 2 billion for a total of 16 billions. XOR. Does everybody knows about the XOR? XOR is a DDoS attack that hits actually Linux machine, Linux boxes. It starts with kind of understanding or sniffing if SSH is vulnerable. If it is, what the attacker does is he starts trying to pop up a bash with root access permissions, download the malware, and it copies into different directories. One is the boot, the other in the UDEV. And notice what is interesting here. In the UDEV, only root has read permission. There are no other kind of permissions. So it can only be run from the boot sector. To give persistence, so to know that even if after rebooting, it copies themselves also in the init.d with all the permission needed to run. Then what happens, the machine infected, the zombie, talks back to the command and control, gets back the statement to understand that he's authenticated and on port 3502. And this is the payload that he gets back from the command and control to the client. It is encrypted. It is encrypted. It is encrypted using XOR. We understood that it was after analyzing it. And we created a small script to try to decrypt it. If you check the second line, we get a key. Finally, we were able to retrieve the key. So XORing against this key, we got the plain text. And the plain text contains just instructions on what the zombie has to do. The zombie has to attack, and the first 28 bytes are actually unencrypted. Just the payload is encrypted. What it does mainly is, okay, it has the checksum. It has the command to execute. You will see below the second line as a 0.5 highlighted. It can run two kind of attacks. One is 0.5 and one is 0.4. That's the command for them. We will see which ones they are. And it also tells the target and the number of targets that it has to run. So it can go for 0.4, SymFlood payload. Check the window. Windows is 65535, so it's widely open to ensure that the attack goes ahead. And the DNS float payload, 0.5. What is interesting also, it instructs the client to spoof the original address, but just on the last 2 octets. And that is pretty interesting because it prevents the reverse path forwarding to be blocked. In case the ISP is using reverse path forwarding, and you spoof also the first 2 octet or just the second octet in case of a B class, what happens is you can have your packets dropped. With this technology, it's almost impossible to block it. Plus, we just don't rely simply on the data that we see, on the data that we analyze. Naturally, this analysis is fundamental for us. We will see later there is a spam bot that we have analyzed that actually came from a customer saying, hey, can you please analyze this? We also check what is really going on. We are on the chat. We do understand, it's difficult to read. This is again the FIFA IP address. So what happens is sometimes we're causing problems to the bad guys, but not only. We also use this to check what are the technologies used to attack actually. What are the best technology in use, what is the trend, what is going on. And once we can analyze them, what we do is we publish them in our report. What happens then in terms of application attack? In terms of application attack, again, we have a situation where local file inclusion is widely used and widely deployed. And only 11% of these attacks at application level, so layer 7, are using encrypted channels, so HTTPS. Out of the sum of them, application layer DDoS is just 3.11%. Infrastructure layer is still the best. And whatever is using just HTTP GET, more or less. On the market, what happens? More or less the same that happened before. It's hitting a lot the retail industry. It can be because of competition. It can be because of, also botnets are coming in to try to understand, to grab the pricing and probably to sell it at a different price, lower than the competitor. And still, media and entertainment, hotel and travel, and financial services, they all have huge databases which are fundamental. If you're able to retrieve this kind of information from those databases, they have very sensitive information in them because they run also online payment, stuff like that. Plus consider media and entertainment. I have actually television on demand on the internet at home. Television is moving from antennas and cable TV over the internet. And, this is another trick that can happen. What if you can block a broadcasting television over the internet? This is the spam bot that we were talking before. It's called Tort. Tort actually comes from an Italian word for cakes, because it's sliced like a cake. And what happens with Tort spam first tries to understand if it can infect the machine. It's, again, working mainly on Linux stuff. It first starts to understand the architecture, so if it's a 32 or 64-bit kind of architecture, and then download a file which is called cronD. It is, again, encrypted. We didn't have the decryption, but we saw this variable was pretty interesting to us, so we're trying to start decrypting from there. And it was kind of a pain because it was not, we thought it was firstly base 64 encryption standard, but once decrypted, it was meaningful, it was grabby stuff. So what we did is further investigation, we realized that this is again an XOR kind of encryption against number 2. Instead of a key, it's just against number 2. And when you have it decrypted, what you get is the URLs, let's call it, of the command and control, anyhow, of the servers that are actually then downloading to the client the email list that they would like to attack, as well as the method. Actually, it implements both methods, PHP email send. If it's not working, this is the preferred. And if you go through the actual script and the actual listing, you will see and you will understand that if it is not working, then it immediately switch to just raw socket. So it will still work. And it starts sending out spam emails. Then there is vulnerability scanners. They are still part of the bot. What is happening here in the space of the vulnerability scanners to understand what you can attack actually is Telnet is still the preferred. And we realized that probably Telnet is not still the preferred just because it's clear text, it's easy, just brute force the password or password guessing, whatever. It's not just that. The point is, if there are companies that are running Telnet instead of, for example, SSH or other kind of things like this, encrypted, it means that you will probably easily or easier than in other companies find other vulnerabilities, because probably the configuration of the company is not that perfect. And so that's why Telnet is tried, not just for understanding Telnet, but for understanding the general posture of the company. In terms of scanners, what we saw passing into our platform, local file inclusion. This is a test which tries to get control over WordPress, the configuration file of WordPress, using directory traversal, the red part, // is directory traversal kind of attack, and WP is under -config.php is actually the configuration for WordPress, so taking over the WordPress. Either they can try with command injection. What that can do is they try just to put to sleep the machine for 20 seconds. If the machine goes to sleep, then below there is the decoded attack just for easy reading. If the time goes for 20 seconds, the machine goes out, then we know it's vulnerable, and they know it's vulnerable actually. Either try to install Lobex using the PHP open-flash chart, which in a subroutine, which is the managing of the name for uploading images is weak, can have vulnerabilities inside, and you can try to install Lobex 21. Lobex 21 is actually backdoor. This is a web shell, but you can install both backdoor, either web shells. And SQL injection. This is coming actually is surely from an automated tools. If you check the last part of the second line in red, you see burp collaborator.net. It actually comes from the burp part swigger. It's a test. They try to get in the port and try to have content back to this address. If the address is there, then they know the application is vulnerable. And the last two, RFI, again, Frax PHP, using a subdomain of Flickr. Subdomain of Flickr can be vulnerable. There are machines that are still vulnerable to this, so remote file inclusion still works. And the last one that we see as an example here is the same as before, is again, trying to set the sleep command. Sleep command not to the architecture, to the environment, really, but to the SQL server. So the same function, sleep, can be run against the SQL server to understand if it's vulnerable. And we have something to manage the bots as well. We see a lot of botnets coming in. Botnets can be, both can be good, can be bad. And the problem is, if you block them, what happens is the bot manager will understand it more an hour later, and we'll try to get a different bot to rephrase it, try to have a botnet better, so that he can run it again, and it will go unnoticed, completely unnoticed. So probably the best philosophy is not to block a botnet, but to manage it. Manage it means, let's understand, first of all, do we want the botnet, or do we don't want? There is one which is called Googlebot, ranking on the internet. You probably want it. Partner botnets, in case you are selling something online and you have partners, you might want this bot. Other botnets are bad ones, so you don't want them. So what we can do, you can serve alternate content. You can block them, indeed. You can just rate limiting. So if they're coming too fast, maybe there are good ones, but they're coming too fast, you can rate limiting them. And so managing the bot is much better than blocking them completely. If I have the network connection, I can go for a quick example of it. It doesn't share, actually, I don't. I thought I could, but this doesn't work actually with the web. Anyhow, what we do in this demo is what we can do is using both sides, one with sort of botnet management and the other ones without. We can try to retrieve using a simple bot which is publicly available. It's called magic.io. It's run actually on Amazon and is there for purpose, is there for testing, so it's a legal one. We can use it. What happens is from the unprotected web server, we get all the price list. Is a web server open cart. Some of you may know it is also a template for e-commerce. What we can do is we can retrieve all the price list with all the discounts, all the things like this was $100, now is 90 or whatever. With a protected site, if you try to run the bot, retrieve the content, what you have is the same price for everyone. So $10,000 flat on all kind of products, on all kind of service sold. So the bot will never know what the actual pricing is, and the bot manager will be never able to retrieve the actual content and make some marketing activities or try to lower the price or, you know, tricking you. So from my side, I am probably running also out of time. I'm over, I guess. Do you have any kind of questions or?
Thank you for great talk. I have two questions. One about botnets. How often do you see commands to bots that are encrypted so hard that you can't decode them? Is that a real deal? And second question is about IPv6. How are the attacks going in IPv6 internet?
I'll start from the last one. IPv6 is still coming. So we don't see that much. We have very little traffic in terms of IPv6, in terms of DDoS, so, but it's coming in. We're ready, our platform support it, but we don't see that much indeed, because also the internet is not really using that much IPv6. Talking about the botnet, yes, but we are normally able to understand upfront from signatures. So still the IP header needs to be in clear text, and we can categorize them. We have, let's say, we create our signatures to understand what the bot is and which bot is using parameters. We know some of them, they're already defined, predefined in our platform. Others are customizable. So we can customize how to understand it from the header mainly. You're welcome. Any other question? My colleagues doesn't have any question for me.
Maybe I have one question. Okay, you said about managing bots and botnets, and I would like to know more maybe about when the botnet is really malicious for the systems. Isn't it better to block it even for a I don't know, day, week, to prepare more for this management of this botnet, or just killing the traffic from the bot?
Yeah. Well, the point is, if you block the botnet, what happens is there is no actually return to the manager of the botnet. So he will understand that something is going wrong. So it's better not to block it, because he will make modifications on the code and will make it more sneaky, more undetectable, and it will return from time to time. So blocking is really when it goes to the burst of a DDoS, actually. But in other cases, it's better to go for other kind of things. The first one is serve alternate content, just to trick around the bot itself. The second one is indeed rate limiting. So if it's coming in with too much let's try to slow it down. We can put delay for 2 seconds, up to 8 seconds, 10 seconds, so the requests are coming in very slowly, and we can free the bandwidth for the actual usage of the web server itself. So those are the two main techniques that we use for managing the bots. They're the most widely used also to our customers. You're welcome.
Okay, about protecting about botnets, is this a good solution to add some honeypot, like redirecting preparing some solution, some fake system with fake data, and do you use this kind of protection like honeypot during the attacks of the botnets?
Definitely. That was actually the meaning of the demo, but it's looks like the video is not going good. Anyhow, yes, what we do is we try to serve alternate content, and it's always a good idea. Sorry, not just if you're with Akamai. I mean, in general, you can put on your own honeypot and give back fake information to the bot.
And after that, analyze.
Obviously, yes. That's why we have 2 petabytes of data.
Okay.
Store them. Yeah, let's make an honeypot or a gray website, alternate content, whatever. It can be a single page or whatever, keep it, and then redirect. Serve the content, store the logs.
Thank you.
Pardon? Yeah, serving alternate content is actually not just because you're freeing your bandwidth for use, but it's also giving false information back. Consider if it is a competitor who want to understand what's your price list online, if you're selling shoes, for example. He wants to understand what's the price for your shoes, if you have any kind of discount policies and whatever. You know, on an e-commerce website, for example, it makes a lot of time of effort if you do it manually, because you have to serve all the single pages, take down the numbers and whatever. Better to set up a bot, retrieve all the content, and then checking it, whatever database or whatever. If you're able to provide the bot manager with a fake content, he will never understand what your marketing policies is at the moment. Opposite to, I don't know, let's think about Booking. Booking relies on hotels and other things that are effectively, they are botnet, but they are good. So you want to have the traffic. That is the sense of managing the botnet. You should first understand which bots I would like to have, which bots I would provide them with the right and the correct content, and which ones I don't want them. If I don't want them, don't block, unless they're gonna up to DDoS level. You agree? Who's next? What about time? Right on time. Left. Please. It really depends. It really, really depends. For some activity on some of our customer, we can have hundreds. For others, 10 or even less. It depends on the purpose of it. In one case, we have seen going up close to 1,000. Mm-hmm. Yes.
Thank you. The question is about mobility, the vector attack of the mobility. The mobility is distributed, and usually to get to the device, you need to go through the to the network, to the
Network operator.
operator network,
Yes.
right? But as well, the device, usually the smartphone, has access to the internet. And do you see any suspicious vector or interesting vectors of attack to the mobility or using mobility?
No, not suspicious. Declared. Last week I was analyzing a bot, which was actually it was a bot used for scanning, and it was fantastic because in the payload, once decrypted, well, it was base 64, so easy stuff. But once decrypted, it said NICTO, 2 words, NICTO. You know, it's a web scanner, as well as BusyBox. BusyBox is a piece of software that you need on Android machines to have them rooted. If the Android machine is not rooted, you cannot run scanning because you are prevented from use kind of conduct of commands on the Android itself. So you first need to root it using BusyBox, installing BusyBox, and then you can run something like Desploit or Fing. Everybody has Fing. Desploit or other kind of. And then NICTO. NICTO, well, probably is from Desploit, but you have also many tools which act like Nmap or whatever. Anyhow, yes. Right last week I was seeing this coming in.
But what about a situation to compromise devices, like because this device is in medium, right? You use the operation network to connect to the internet, but
Yes.
as well, this device could be used to attack the operator network from the other side, from inside.
Yes.
And is this any vector of this to this kind of solution?
Yes, there is, and for example, very easily, if you have a tablet or whatever which is rooted, which is enabled for that, I didn't bring it mine because I needed to fly very light, but it has LOIC on it, and you can run still commands like Zloloris, like CJ, whatever. So you can use that, and actually, due to the power that they have now, you can make up a distributed botnet using that, yeah. Yep, it's not nice, it's scary.
Yes,
On one
scary.
side it's scary.
Yes, but the imagination of the hackers, it's amazing. So
Yeah.
okay, thanks.